Welcome back to our Math 171 video series. In this set of videos, we'll deal with logarithms and exponentials. We're going to begin by learning how to evaluate logarithms. The first expression that we are to evaluate is this expression, which we can read as log base 2 of 32. The base 2 is this 2 that's underneath the log, and we're taking it of 32. What this is really asking us to do is to take the number 2, raise it to some power, which we'll call x, and figure out what x has to be in order to reach 32. So the base of 2 becomes the base of our exponential. The number in the parentheses, the 32, will go on the right, and then our job is to figure out what exponent x must be. Well, we know 2 to the first power would be 2. 2 to the second power is 2 times 2, or 4. 2 to the third power would be 2 times 2 times 2, which is 8. 2 to the fourth power, we'll multiply by an additional 2. This would give us 16. For 2 to the fifth power, we'll just multiply by an additional 2. If we do that math, we'll get 32. Therefore, the correct exponent to place is fifth power. 2 to the fifth does give us 32, and so we can say that log base 2 of 32 is equal to 5, where 5 is the exponent and 2 is the base. If you take 2 to the fifth, you will get 32. We can do another example with log base 6 of 216. This is the same as saying a base of 6 raised to an unknown exponent, which we'll call x, will equal 216. 6 to the first power will give us 6. 6 to the second power is 6 times 6, which is 36. And 6 to the third power is 6 times 6 times 6. This would be 216. Therefore, the correct exponent is 3. Therefore, we'll say that log base 6 of 216 is equal to 3, because 3 is the correct exponent we could place in place of x to get 216. Now we'll do a log that doesn't have a base written. Our next expression says log of 1,000. If you have no base, then the base is automatically 10. Therefore, we'll say 10 raised to the unknown exponent, x, is equal to 1,000. Well, 10 to the first power would give us 10. 10 to the second power is 10 times 10, or 100. 10 to the third power would give us 1,000. This means the correct exponent is 3, and we can say log of 1,000, or common log of 1,000 if you wish, is just 3. So remember, anytime you have no base written, the base is ordinarily 10. If there's a base other than 10, it will be indicated. The only exception to this rule is our last example, ln. ln stands for natural log. If you see an ln, this is just a log with a base of lowercase e Euler's constant. We can rewrite this as log base e of e to the 7th power. Now notice that we are taking a log with a base of e, and we also have an exponential with a base of e. This brings us to our first logarithm rule. If you're taking a log and its base is the same as the base of your exponent, those are inverse functions. Most importantly, because they're inverse functions, they can cancel one another out. This means that the log base e and the base e exponential will cancel out, and this will leave behind only the 7. We'll cross off both the log base e and the exponential e, and only 7 is left behind. Therefore, we can say ln of e to the 7th is just 7 because the ln and the base e exponential are inverse.